Stop what you're doing right now, because what I'm about to tell you will completely change the way you look at the sky forever. Most people spend their entire lives never knowing that the sun, the one thing we're told drowns out everything else in the daytime sky, can actually share its stage with something so bright, so violent, and so jaw-dropping that witnesses literally pull over their cars in shock. We're talking about daylight fireballs, and once you understand what they actually are, you'll never look up the same way again. Here's the thing that most science teachers never told you. Space doesn't stop throwing things at Earth just because the sun comes up. Every single day, our planet is bombarded by an estimated 48.5 tons of meteoritic material. Let that sink in. 48.5 tons. Every single day. Most of it burns up quietly, invisibly, and harmlessly in the upper atmosphere. But occasionally, something big enough, dense enough, and fast enough punches through that atmospheric wall with so much energy that it produces light brilliant enough to be seen in broad daylight. That object is called a fireball, and when it appears during daylight hours, it earns the extraordinary title of a daylight fireball. Now here's where it gets controversial. You've probably heard the phrase, seeing is believing, right? But for centuries, when ordinary people reported seeing bright flaming objects streaking across the daytime sky, scientists dismissed them. Farmers, sailors, and travelers who witnessed these events were essentially laughed at or called liars. The establishment position was simple. The sun is too bright. Nothing could compete with it. You must be confused. And that, right there, is one of the most embarrassing chapters in the history of science, because those people were telling the absolute truth. A daylight fireball, technically classified as any meteor brighter than magnitude -6, can produce luminosity that rivals or even temporarily surpasses the brightness of the full moon. The full moon, visible at night, has a magnitude of roughly -12.7. For something to be seen during daytime, it typically needs to reach between -6 and -14 in magnitude. These are not gentle glowing rocks. These are objects traveling at speeds between 11 and 72 kilometers per second, generating plasma temperatures that can exceed 1,600 degrees Celsius on their surface as they tear through Earth's atmosphere. The friction, pressure, and chemical reactions involved create a light show that the sun itself cannot suppress. One of the most documented and scientifically significant daylight fireball events in modern history happened on February 15, 2013, over Chelyabinsk, Russia. This wasn't just a fireball. This was a wake-up call for the entire planet. The Chelyabinsk meteor entered Earth's atmosphere at approximately 19 kilometers per second. It was bright enough to be captured on thousands of dash cams, security cameras, and smartphones in broad daylight. The shockwave it produced shattered windows across 6 cities, damaged over 7,200 buildings, and injured approximately 1,500 people, mostly from broken glass. Scientists later estimated that it released energy equivalent to about 400 to 500 kilotons of TNT, roughly 26 to 33 times the energy of the Hiroshima atomic bomb. And here's the gut punch. Nobody saw it coming. Not NASA, not any space agency. Zero warning. Now before you start feeling helpless, here's something that should genuinely excite you. The scientific community has made incredible strides in detection since Chelyabinsk. Programs like NASA's Center for Near-Earth Object Studies, the Catalina Sky Survey, and the newer Vera-C Rubin Observatory currently under completion are scanning the skies with unprecedented precision. As of 2024, NASA has cataloged over 32,000 near-Earth objects, and that number grows monthly. Our detection capability today is fundamentally superior to what existed even a decade ago. The planet is not defenseless, and human ingenuity is working overtime on this exact problem. But here's what makes daylight fireballs particularly fascinating from a scientific standpoint. Because they occur when the sun is up, they are often visible to far more people than nighttime events. The daytime population is awake, active, outdoors, and carrying smartphones. This means that when a significant daylight fireball occurs today, it gets captured from multiple angles almost instantly, giving researchers a data goldmine. Triangulating the trajectory, estimating the mass, calculating the entry angle, and even predicting where meteorite fragments may have landed becomes far more accurate. In essence, the very thing that makes daytime seem like an unlikely time for cosmic drama actually makes it scientifically rich territory. There's also something deeply philosophical about daylight fireballs that never gets talked about enough. For most of human history, the sky was divided. Night was mysterious, full of stars, comets, and wonder. Day was ordinary, predictable, safe. Daylight fireballs shatter that psychological wall completely. They are nature's reminder that the universe operates on its own schedule, with no regard for human convenience, human comfort zones, or human assumptions. The cosmos does not wait for dark. The next time you step outside on a perfectly ordinary sunny afternoon, understand that somewhere above you, right now, pieces of asteroids and comets are intersecting Earth's path. Most will burn invisibly, but every so often, one refuses to go quietly. It blazes across the blue sky, demanding to be seen, demanding to be acknowledged, reminding every single person who looks up that we live on a tiny rock hurtling through an active, dynamic, and occasionally violent solar system. If this blew your mind even a little, follow this page right now, because we cover the most extraordinary, verified, and mind-expanding science the universe has to offer, and we are just getting started. Now I need to ask you this directly. If you saw a fireball streak across the sky in broad daylight today, would you know what you were actually looking at? Or would you reach for your phone to film it before your brain even registered what was happening?